what we're doing is now we're going to look at the calculations about just know what the limits are. Plus 10% of 400, minus 6% of 400. Also plus 10% of 230 and minus 6% of 230. We go through the long-winded process and then I'll show you a quicker way to do it. So if we get 400, yeah, we're looking at the upper limit now. So 400 divided by 100, put that in brackets, times it by 110, which is the 100% added the 10, equals, and that's going to give us 440 volts. So that's the upper limit. Anything above that would have to inform the supply authority and just let them know, because obviously they would have to sort out that that's their responsibility to give us a supply which is below that value. Now what we're going to do is we're going to look at obviously the downside, the lower limit that we're allowed. So it's the same process, almost. 400 divided by 100. Now we've got to take 6 away from 100, which leaves us with 94. So we times it by 94. Let's do that quickly on the calculator. 400 divided by 100 times 94. Now that's 376. 376 volts. So that's the upper limit and that's the lower limit. Now I'm just going to show you a quicker way of doing this. You could do 400 times 1.1 and that's adding the 10% on. You could also do 400 times 0.94 and that will give you 94% and you'll get exactly the same answers. So as long as we understand they're the limits, as long as we're between those two values when we're measuring the voltage, okay, that is what we call an acceptable value. Let's look now onto the single line voltage. Same process, 230, you divide that by 100, then you times by 110, and that I believe comes out at 252. So it's 230 divided by 100 times 110, it's 253. So we've got 253 volts. That's the upper limit that we're allowed. The next step is obviously find the lower limit. So same again, 230 volts divided by 100 times 94 equals, so we've got 230 divided by 100 times 94 equals 216.2. 216.2. We could do exactly the same principle, how we've done 400 times 1.1. We could also do 230 times 1.1. We could also do 230 times 0.94. Okay? And that's how we're calculating the plus 10% and the minus 6% of our nominal voltage. What we've done is we've looked at the nominal voltages, and now what we're going to look at is how we're actually going to physically measure the voltages and the theory behind that. There's a very easy way, or it's very easy to miss out a process when you're talking. You've got all these different terminals that you've got to put your leads on. I'm just going to show you a quick demonstration of a fail-safe way of carrying out a voltage check or any kind of continuity checks on an installation. If I've got, it's very important that you put your neutral conductor on first. You shouldn't put your lead onto a live terminal before you put it onto a neutral or an earth terminal. For the simple fact of, if you put it on with the lead, potentially you could have a potential difference between here, hence giving you electric shock. If you put it on the neutral first, and then onto the live conductor, you're reducing the risk of getting an electric shock when carrying out your testing procedure. So, first things first, what we've done is we've put our neutral lead from our meter onto our neutral conductor. That's that one just there. Then what we're going to do is we're going to go test to there. So that's neutral 12.1, then neutral 12.2, neutral 12.3, then neutral to earth. Now it's very simple, we've put it on there, we've gone 1, 2, 3, 4. Now we're not looking at the values that we're just talking about, the theory and the principle of measuring, okay? So effectively, we've done every possible combination now that is to do with the neutral conductor itself. So we can almost get that one out of the equation. The next step now, we're going to use L1. Now previously I've stated do not put your leads onto a live terminal. There's nothing we can do about this here, we've just got to be extra safe. We're going between two live terminals. So it's you've got to be very careful. Again, always get into good practice by putting your neutral lead on first. Then you're going from L1, we don't have to go back to neutral, remember, we forgot about that one now. 12.2, 12.3, then to earth. Now we've done every combination with L1. We've done the L2, L3 and earth and the neutral already, previous. So we can now pull that back. And effectively our L1 terminal and our neutrals has had all its combinations used up. So the next step, it can be very repetitive, but again it's a fail-safe method. You go between the L2 to the L3, then to the earth. Same again, we've done every combination possible between the L2, so we can almost eliminate that out of the way. And the final test is L3 to earth. Now obviously you should really put it on the dead conductor first, or the earth terminal first, prior to doing it. Where you've got that facility available, when you're testing between a neutral and a line, or an earth and a line conductor, it is always good practice to put your neutral onto your earth first, really, and then go to your line conductors. So that's the actual process of how you're going to be testing between them. Now what we're going to do is just look at the theory here. We tested between neutral L1, neutral L2, neutral L3, neutral and earth. And if you look, 1, 2, 3, 4, 4 neutrals. 1, 2, 3, 4, 4 L1s. 1, 2, 3, 4, 4 L2s. Lo and behold, 1, 2, 3, 4, 4 L3s. And as you can guess, 1, 2, 3, 4, 4 Earths. Yeah? You have hit every single combination possible to do with that isolator to check the voltages that are there. And you follow the same process when you're doing safe isolation. So now we've got the theory out of the way, what we're going to do is we're going to actually put into practice and record the values that we're actually going to measure. Now it's very important when you're going to be using this again. There's 400 volts within this unit, so we must be careful. I've opened it up. Previously I'd taken that out, and we've got the terminals exposed. These terminals at the bottom are live, so do not go doing anything silly by sticking your fingers in or anything like that. You will be stopped by your invigilator and you will fail your exam. So we need to see that you're calm, collective and working in a safe manner. If you breach any kind of safety procedures, we will instantly terminate your exam. So, back to your meter. As we've previously discussed, we've said we need to put it on the 750 volts with the sine wave symbol. You can see there it's reading as 0. Check again that the leads are intact. It's got finger guards fitted, and it's got tips with the exposed part of no more than 2 millimeters. The first test we're going to do, we're going to put the neutral lead onto the neutral itself. Then we're going to put the live lead or the line lead onto L1, and we're going to look at the value. And the value that it's coming up with on the meter that we can just see just here is 242 volts. So we can go back, let's get the pen, 242 volts. Now it's pretty generic, we're just going to repeat the processes that was previously stated. On neutral again, down to the next line, 245 volts. Now we are expecting, this is a single line supply we're testing because we're going between a neutral conductor and a line conductor. And to there we've got 244. Now they are within the same region of each other. You tend to find on installations, if there is going to be voltage drop on any one of the lines, you tend to find it is your L1 or your brown conductor. The reason why is that is the one that's used generically more than any other. Now between neutral and earth, effectively, we shouldn't get any kind of voltage there, which is good, because neither of these conductors are a line conductor. The neutral is considered to be a live conductor, but he's not a line conductor, so we've got 0 volts, and I'm happy with that. If you had a voltage there, it can be down to poor power factor within an installation, causing the neutral to carry excess current. So now this is where we're going to be measuring the 400 volt. You need to be extra vigilant for this, okay? So you take your time, just put your neutral lead on first, go between the two protected devices. You'll see that we're measuring underneath. Remember, the top terminals will be isolated because they are isolated mechanics. Again, following the process, again L1 now to L3, 423, same voltage again. It's good, we're getting quite stable voltages between them all, which is a good sign for, it shows a balanced load. Within an installation you've got even loads across the installation. Like we said before, now I'm not going to go onto the line and earth. I've got the facility to go onto the earth first and then onto the line. So we've got 243. Now with this one I've got no choice because it's between two line conductors. Now with the final two, I'm going to be going through to the earth again. Neutral lead onto the earth first. I've got 245 and 244. So looking at it now, what we've done is we've measured the voltages successfully. We've done it in a safe manner. We've checked the equipment over prior to use. From the values that we've obtained, we can see there we've not exceeded or gone below on the single line voltages. We've not gone over 253, and no, we've not gone below 216. We're also on the three line system not gone over 440 volts. We've most definitely gone below 376. So the voltages that we've measured to be carried out in a safe manner, and they are acceptable. And that's how you measure three line voltages.